Hello again, people. Today starts yet another project which I have been wanting to do for a long time. And it is a crane, and I'm gonna build two of them. One is gonna be behind my large lathe, and one is gonna be here in this main room, where is my milling machine right here. And when I get my 1K65 lathe running, I think I'm gonna move it somewhere within the range of the crane, so that the same crane can load both the milling machine and the lathe, and maybe something else, but I'll have to think a little bit more about the layout. But now I'm gonna build the cranes, and I think I'm just gonna build one of them first. And on this piece of paper, let me show you what it's gonna be like. So it's gonna be a rotating radius kind of crane. So the floor is here, and then there's gonna be a pillar right here, which is a piece of pipe. And then I'm gonna weld on top of it a shaft which is made of solid steel. And then ceiling will be here. And then I'm gonna have a part in here like this, which is made of thick walled pipe. And I'm gonna have it rotating around the upright beam. And right here on the lowest part of the rotating piece will be the beam. It's actually much longer than this. And then it's gonna have a support coming from the upside of the rotating piece to all the way to the end of the beam. Okay, and the bearings will be here. In the bottom there will be a thrust bearing, ball thrust bearing, and which is gonna take the axial loads, so the main weight of the piece being lifted up. And then taking the radial loads, there will be two deep groove ball bearings right here. One is here in the bottom part, and one is here, up here. And it's gonna have slip fits everywhere, so it's gonna be easy to install and put together. And the bottom part right here and the ceiling part right here will be bolted to the floor and to the ceiling. And I had a little bit of a wrestling match going on in my head, whether to make the whole beam to turn or make a piece that turns right in here. And it would be much easier to make it so that the whole beam would turn, so there would be one bearing point up and one bearing point down with exactly the same kind of bearings. And it would actually be much easier for these ball bearings which take the radial loads. But there is one issue which I'm not quite sure if it's much of an issue. I think it is actually. This is an old building, and the roof casting, concrete casting, and the ceiling concrete casting are very rough, and there is no way I could get the alignment correct for the bearings. So I know they would not last long, or they might even break right away. So this is why I ended up doing this. It's putting more stress on the bearings but I have calculated that they will be strong enough. If I remember correct, the radial bearings are 6012 2RS, made by CX, and they take around 25 kilonewtons of force, radial force, static, and it's dynamic almost the same, but they're turning so slow that it's static all the time basically. So I was thinking if this is 60 centimeters or 2 feet, and I have a load in here which is 4 feet or 120 centimeters far, and it weighs 1000 kilograms, which is maybe 2500 pounds. Right here. So, and this is, whoops. Oops, sorry, I'm messing. So this is 4 feet, and this is 2 feet. So if I have a load hanging in here like this, it's gonna be double the load in here. So if I have 1 metric ton load of here, it's gonna be 2 kilonewtons. I mean 20 kilonewtons here, or 2 tons. So at about half the beam length, the crane is able to lift 1000 kilograms, which is exactly how much my chain host will lift. And this should be enough, easily enough. And the truss bearing is no issue, because the shaft in here will be 60 millimeters in diameter. If I remember correctly, the truss bearing can take like 40 to 50 kilonewtons, which is 4 to 5 metric tons. So that's gonna be no issue at all. So this is how I'm gonna build it. Anyways, be it the best idea or not, but I've decided to do it like this. Okay, and also this pipe is around 110 millimeters in diameter with a wall thickness of 5 millimeters. So it's about 4 inches by about 200 thousandths. And the beam right here is an IPE 120. And this rod right here, support rod, will be made of 42 CRMO4 steel, which is, I think it's like 4140 steel, pretty much. And I have calculated that if the thickness is 20 millimeters, it can take a load of over 100 kilonewtons, which is easily enough. And I'm gonna make in here like these pieces, which will attach, it's gonna be like links with a bolt going through, and that's gonna attach the support pieces, and the same kind of supports will be here. So this will be removable, and also in here I will have a bolt connection, detachable connection with bolts, so it is easier to install it. Okay, so 2 of these will be made. And by the way, this pipe here, this beam, I am not sure what kind of a material it is because it came from a scrapyard. But assuming that it is S355 steel, which is the most common structural steel in my country, it will be strong enough. So of course it will want to push here, or actually it will like to bend it in here, but because this point is so high, so close to the supporting point, it will only act as pressing in here. And it will be strong enough. I did some stress analysis, just hoping that it actually is as strong as this material. Okay, so, and also the pipe is galvanized, so I have to remove it, the galvanizing, before I can weld it. I hate galvanized pieces, but that was the only one that I could find. Okay, now let me show you around a little bit. So here you can see two pieces of IPE to 120 I-beam, about this size, not very large. And the one that I used to build my gantry crane was IPE 140, so this is a little bit smaller. But also the distance, the length is shorter, so the load bearing capacity is pretty much exactly the same, so it can easily carry 1 ton in the middle. And right in here I have two pieces of pipe. Well, this one's a pipe, it's a thick walled pipe, and this is a 60mm solid steel piece. And again, I have no idea what this material is, but I'm 99% sure that it will be S355 or stronger. Probably both of these are much stronger. So they will be good enough. And this will be the outside of the rotating piece, and this will be the shaft that's gonna be welded to the pipe. And both of these will be cut in the middle, so I can make two pieces, two cranes out of them. And what's a little bit of a problem, the inside diameter of the bearings will be 60mm, and this is a 60mm rod, so I have to measure it carefully and see if there's enough material over 60mm to clean it up to 60mm, but I think there won't be, so I guess I'm just gonna have to weld fill this a little bit, which I don't like, but that's the only way to go, because I don't have a better material for now. And the pipes are here. I think these used to be light posts. As I said, they came from a scrapyard and they cost almost nothing. And what I already have here sitting on my lathe, I have indicated it and it's ready to be turned, is the piece where the bearings will sit. This is a little bit larger than the pipe that I just showed you. And the problem with this thick-walled pipe is that it's too small for the bearings. So I'm gonna have to take a piece of this and weld the bearing houses made from that piece to both ends of this piece. So it's not gonna be exactly very simple, but it's fun work. And I just ordered the bearings, but they're not here yet. But I think I'm confident enough with their dimensions that I can already finish all the parts. And what I'm extremely anxious about is what I have here. Take a look at this, can you see? My Sandvik Coromant tool order just came in today. Let's see if I can open this. It's a brand new Sandvik Coromant tool. The first ever that I have bought new. Just loving this. So it takes a CNMG 12 tool. And it's a 25mm or 1-inch shank. Just loving these. And I got 2 sets of inserts. This is an all-round insert for roughing. And I must say I'm kind of confused about why he suggested these inserts for me. Because this GC15 grade seems to be mostly for superalloys. But I guess that also makes it good for different kind of materials. So this should be good for steel and stainless steel and cast iron, and seemingly also for superalloys, which is S. But what I'm gonna do mostly is P, which is steel. So I can take from 75 to 6 millimeters of diameter, and in imperial measure it's here, and the feed will be 0.18 to 0.3 millimeters, which is quite low, I think. And cutting speed 100 meters per minute, which is, I think, pretty normal. But what's weird is these finishing inserts. It only gives cutting parameters for superalloys. And that's quite weird, but maybe, I hope this is still meant for steels also. I think I have to contact the sales guy and ask. I still haven't opened this package, so I can still return it. Because I really won't be doing any superalloy stuff anywhere near soon. So I'll have to give him a call or email. But I'm gonna start with these roughing inserts. Okay, I think we can now start working on the piece that's already in the milling machine, I mean the lathe. And we have a bumblebee in here. Nice. One of the first in this spring. I'm having my door open because it's almost warmer outside than it's inside the shop. Okay, enough talking. Let's get some work done.